we're going to be talking about similar triangles, which we've done some with before, and we're going to begin working with something called polar coordinates. That's going to be the really new and different part. So first, I want us to think about the similar triangle piece of all of this. And let me see a response from you guys. Do you think these are similar triangles or not? So type yes or no into the chat and hit enter. Now more than 3 of you in the class. I should see some other. So they are indeed similar, and we want to think through how we know. Well, we already have 2 angles that are congruent. We know if we can get all 3 sets of angles to be congruent, it will be that they will be similar triangles. So I need somebody to help me understand, why would these 2 angles also need to be congruent? So what's a reason for those 2? So type it in chat and hit enter. So very good. Those are vertical angles. Then if I have 2 angles that are congruent, how do I know that the 3rd set has to also be congruent? Unmute or type. Sort of triangle some, but that would be the long way to get there. We've learned that the shortcut is to say, if we know 2 sets of the angles match up, the 3rd one will automatically match up. So AA and then an arrow, not equals. AA implies AAA. So yes, they are similar. Now, what is important to remember, when you have similar triangles, your corresponding sides are across from, I don't like the way that's done. So I'm going to do it a different way. Your corresponding sides are across from your corresponding angles. What that means for us when we set these things up. Okay. If I go across from the 3 hash marks, A and D are corresponding sides. If I go across from the 1 hash mark, B and C are also corresponding sides. That one looks a little more like an A. And they aren't labeled, but the 2 unlabeled sides would also be corresponding sides. So once I have thought that through, I can set up a proportion and solve for D. I know that A and D are corresponding sides, so I can say A over D. And B and C, we set our corresponding sides. And let's see, now I have to be careful. I started with the triangle on the left when I wrote A over D. So for my fraction on the right, I have to start with the triangle on the left again and say C over B, so that I did both of those as left over right. And then if I wanted to actually solve for D, I could do my cross product here and say AB equals CD and divide both sides by C. And I have that D is AB over C. So the trick in setting it up is look for what's across from the corresponding angles. Okay, that's it for similar triangles. We'll use them in some places, but let's switch over to polar and rectangular coordinates. Rectangular coordinates are what you are used to using when you do 3, -4. You go across to the right 3, and then you go down 4, and that point is where you are in the coordinate plane. We also write those in vector form. So 3, okay, I've got positive 4 here. I can do 3i hat plus 4j hat. Now your book is going to use R and U, and I am going to count it wrong if you use R and U. So just because the back of the book says R and U, I do not want you copying that down. I want you using I hat and J hat instead. That's to make it consistent with your other math courses here, with physics, just so that you're not learning one thing this year and then unlearning it and learning something different later. We're just going to start off the way that's consistent for all of the classes that you will be taking. Now, a vector is a little bit different technically than just a point. A vector has an arrow on it. So if I wanted to graph this 3i hat plus 4j hat, what I would need to do, this way, would be to go 1, 2, 3 to the right, because I hat comes first. This direction is the I hat direction. This direction is the j hat direction. I'd go 1, 2, 3 in the positive I hat direction, 1, 2, 3, 4. But my vector would be an arrow that starts at the origin and ends at that point. So it's not just the point, it's the whole arrow. It's the direction and length. Now, if I wanted to, I could think about that as making a triangle, always with the horizontal axis. So triangle always with horizontal axis. So now I'm interested in this angle right here, which I am going to name theta. The angle that I am going, so theta is always, if this is my axis, theta is some angle that starts at the I-axis and goes around counterclockwise. Now, if I wanted to know how big that angle is, let's think about how we made this triangle. We went 3 along this side, right? And then we went 4 up on this side. So for that angle that I labeled theta, I know my opposite side is 4 and my adjacent side is 3. And I know a trig ratio for that. I know that that means the tangent try that again. That means the tangent. I will be so glad when my board works again and I don't have to do it this way. So the tangent of theta is going to be the opposite over the adjacent 4/3. So if I want to know the angle, Cannon, you need to be writing this down. Everybody needs to be taking notes on all of this. This is really important today. So the inverse tan of 4/3 would be my angle. And I could punch that in the calculator to get it. And we're going to use that idea on a lot of problems. Now, we know when we are talking about graphing things, if I am in this first quadrant here, everything's positive. If I'm graphing a point, it's a positive x and a positive y. If it's a vector, it's a positive I hat and a positive j hat. Same thing for the other coordinates. If I am over here in the second quadrant where I'm used to negative x and positive y, it's now negative I hat and positive j hat. I guess technically those should have my little hats on them. I just couldn't get to type there. And third quadrant, both are negative, and fourth quadrant, I hat's positive and j hat's negative. I'm wondering, have any of you ever used a compass to do any orienteering? Maybe in Boy Scouts or Girl Scouts or something, you had a little bit of practice with that. Or you've watched some movies that have talked about, some things with military and having different coordinates. They will talk about going in a certain direction for a certain distance. Maybe it's going so many degrees north-northeast or something like that. And whether you really understand what that means or not, it's like, oh, kind of in between north and east, but north-northeast would be closer to north. And then I'm going to go 5 miles that direction or whatever the distance is. That's what polar coordinates do. They talk about a direction and how far you're going to go. Rectangular coordinates say how far left and right, how far up and down to get there. So it's kind of like you go along 2 sides of a rectangle to figure out where you want to end up. Polar coordinates are, well, what if I want to just go along the diagonal to get there? So if I go back to this picture that I had, rectangular coordinates are what I've drawn in black on this triangle. Go 3 across and 4 up, 2 sides of the rectangle to end up at this top vertex. Polar coordinates are if I go the diagonal of that rectangle. Go this direction 5 units, and I know it would be 5 because it's a 3, 4, 5 triangle Pythagorean triple. So that means if I wanted to, in polar coordinates on this one, I could figure out how long the hypotenuse is. I could use the Pythagorean theorem if I need to. I'd say I'm going to go 5 for my distance at an angle of whatever my calculator over here ended up telling me that angle was. And that's all that polar coordinates are. So we're going to have an angle and how long it is, which we call the magnitude. The angle theta is always measured from the positive x-axis. So if we go past that vertical axis, it's going to be more than 90 degrees. And we're going to be learning how to deal with that. And it's always counterclockwise. The magnitude r is always how long that hypotenuse is. And we write it like I was just saying, some number at an angle of. So r at theta. Anybody need me to wait, or we have enough written down on what that is? Okay, now if we wanted, do I have down here? If we wanted to graph this thing, 12 at 33 degrees, we are going to start at the positive x-axis, or I hat axis, either way of thinking about it, and we have to go this way. We always go counterclockwise. Now, what we are going to do is to imagine and make our best guess so that it sort of looks to scale, 33 degrees. So that means I don't want to be drawing it up here. That's closer to 90 than 33 degrees. I don't want to draw it so it looks like 45 degrees. I want to draw it so it's a little bit less than that. So I'm going to say maybe about like that. And I'm going to label that that is my 33 degrees. And then I'm going to label that this is 12 units long. And now I have graphed that. All that one said for me to do was to graph it. That much makes sense to everybody. Okay, now we're going to graph 4 at 215 degrees. Okay, now wait a minute. That's not between 0 and 90, so I'm not quite sure what to do with that. We're not really going to use a polar grid like this, but I've got it up here just so you can kind of see what we're talking about. And then we'll do it the way we'd be doing in class. If this is our x-axis and this is our y-axis, this is 0 degrees, up here is 90 degrees, that much makes sense. If we keep on going, a half circle is 180, 3/4 of a circle is 270, and one whole circle brings us back 360 degrees back where we started. So let me put a grid in for the way that we'd be doing these. That's interesting. Oh, there we go. Okay, so what I need to think about, and we would not normally have them, maybe I can get rid of the numbers. Let me see, yeah. I'm not going to worry about the numbers are not on there for now. So if we wanted to do 215 degrees, we'd think, okay, 0 to 90 is in the first quadrant. 90 to 180 is in the second quadrant. So I need to be between 180 and 270 degrees. So if I wanted to, I could look over here at this polar grid. So here's 210. 225 is right at halfway between. So I'm not quite going to be halfway into that third quadrant. So I'm going to draw something that kind of looks about like this. And I'm going to say that's about 4 units long. Now for this one, theta is 215 degrees. That means all the way around like that was 215 degrees. But I need to draw a right triangle so I can use right triangle trig if I want to start figuring out how long, what that would be in rectangular coordinates, which is what we're going to do in a few minutes. So what I would have to do, I would need to be thinking about, always use the part of the x-axis for the triangle. So I would need to be thinking about this triangle right here. I'm going to need to use what we're going to call a reference angle, and I want to draw it that way. A reference angle, we're going to use the Greek letter rho. It looks kind of like a P, and that's going to be our reference angle. And so rho is going to be this little angle right in there. And then if I wanted to get the I hat or the j hat for that, I could use right triangle trig to figure that out. I'd do them one at a time. If I wanted the adjacent side with the hypotenuse, I'd be talking about cosine. If I wanted the opposite side, j hat, along with the hypotenuse, I'd be using sine. And I know that I hat would have to be negative and j hat would have to be negative because my picture shows me I'm in the third quadrant. That much making sense so far? So let's actually do that on this picture. And for this one, I'm going to start out for our first one where we are actually in the first quadrant. So everything's going to be positive, positive. And then I'll go back to doing one and then we'll write down all the steps of what we did. So 4 at 48 degrees. So first thing, you must always have a sketch. If you do not have a picture, the whole problem's wrong. I need to draw 48 degrees. Well, that's pretty darn close to 45. So it's more or less halfway through this first quadrant. That has to work there. So I can then label that this is 48 degrees. Cooperate. It's so frustrating. Okay, we can at least read that. And we label that that side is 4 units long. Now we are going to draw our right triangle. We must use part of the x-axis for one side. So now, since I'm in the first quadrant, I know that I need positive I hat, positive j hat. So I hat is like the x part. So that's adjacent. The hypotenuse is 4. So cosine of 48 degrees is I hat over 4. And now I need your help with the calculators. That means, and I'm going to write it down, that I hat is 4 cosine 48. And I want you to punch that in on your calculator and tell me what we get. So when you've got that, type that in on the chat for me. We got it. Hit enter for me. And mostly I'm seeing 2.677. So if we didn't get that, it's probably a calculator entry error, or maybe your settings aren't on degrees. 4 cosine 48 should give 2.677 for I hat. Okay, now we're going to do the same kind of thing for j hat. So j hat has to be the vertical side. So that means for 48 degrees, j is opposite, and I don't want to use that I hat for 2 reasons. What if I found it wrong, and then I'm using the wrong number, then I absolutely miss j hat also. But also 2.677 is rounded, and we never reuse a rounded number. So I'm going to say that the sine of 48 degrees is opposite j hat over hypotenuse 4. So j hat is 4 sine 48. Calculator help, please. Put it in chat and hit enter for me. And I'm seeing a lot of 2.973s, which sounds good to me. So 2.973 for j hat. I'm not quite finished. I need to write my final answer. Remember, first quadrant, so both were positive. We do not use commas with vectors. We do a plus or minus sign between them. So I'm going to write the I hat part, 2.677 times I hat. And then because j hat is also positive, a plus sign in between, 2.973 j hat, and that is my rectangular coordinate form with vectors. Any questions on that one? Because then I just have one more for us to do here. Okay, this one we are not going to be in the first quadrant, so it's not going to end up positive, positive. So we first need to draw a picture so we can figure out, are we positive, positive, negative? What are we? So that then we can figure out what our positives and negatives, and then we'll figure out our reference angle. So I want everybody to write down a 1, 2, 3, or 4 for which quadrant you think we're in. Where will that 220 degrees be? And you can just do 1, 2, 3, 4. You don't have to do Roman numerals and put in chat. And so I am mostly seeing 3s, and I will scroll back to whatever that was on that last example when we finish this one. So we are down here somewhere in this third quadrant. So let me clean that up a little bit and have a cleaner picture here to start actually graphing it on. So now I need to think about, well, let's see. If I'm going to go to, so I start here and I go to 180 degrees, I need to go 40 more than that to get to 220, so not quite halfway down. So my theta was 220 because that's the whole thing always going from here all the way around. Sorry about that. But what I need when I draw my, well, and I can go ahead and label it, that's 9. Now what I need, though, is a reference triangle that's going to be between 0 and 90 degrees. If you use a negative number, if you use 220 directly into the calculator, you get this whole problem wrong. We expect you to get one between 0 and 90 and write it down. So I need to know, using part of the x-axis as my triangle, what is that angle with the x-axis? It's always going to be with the x-axis, never with the y. So I need to figure out how big that is. And I just do it by geometry. And in fact, I said it a minute ago, because I said when I was trying to figure out where to draw it in the third quadrant, I needed to go 180 degrees, and then I needed to go 40 degrees more. So this was 40 degrees right in here. Now we're going to get I hat and j hat like we did before, except that I hat and j hat will both be negative down here because it's third quadrant. So I'm going to just use right triangle trig to find them, but then I'll put minus signs in front of them when I'm done. So I hat is along the x-axis, so it is adjacent. So adjacent and hypotenuse is cosine. So I write down cosine 40 degrees is I hat over 9. And then I write down I hat is 9 times the cosine of 40 because that's how I enter it on the calculator. And you guys are going to tell me what we get. So when you have that number on your calculator, please type it in chat and hit enter. And 6.894 is correct. So 6.8, come on, 94. But we said in the third quadrant, it needs to be negative, negative. So I'm going to put minus signs in front there so that I don't forget about that. Next, I do the same thing for j hat. It needs to be that opposite side. So for 40 degrees, opposite and hypotenuse means sine. So the sine of 40 degrees is my opposite j hat over my hypotenuse 9. Multiply both sides by 9. And I have that j hat is 9 times the sine of 40. And once again, you guys tell me what that comes out to be with your calculators. Type it in chat and hit enter, please. And great job, 5.785. But we know that we were in the third quadrant, and we know third quadrant, I hat and j hat are both negative. So I'm going to write down that this j hat is really a negative number. And then final step is to put it all together as one vector. So, whoops. Try that again. So putting it all together as one vector, negative 6.894 I hat plus the negative, so I'm just going to write that as minus 5.785 j hat. That making sense to everybody? Anybody with questions on that? And that is the work that I expect to see on all of these, not mental math, not just putting stuff in a calculator and writing it down. So copy down these notes so you don't forget all of the steps. When we have it in polar form and we want to change it to rectangular, you must draw the graph, label your angle, label how long that hypotenuse is. Then you must make a right triangle. So you're going to draw a vertical line going from the end of the vector to the x-axis. Never use the y-axis as part of your triangle. Always must use the x-axis on there. Then figure out how big that angle inside the triangle needs to be. So it's going to be something between 0 and 90 degrees. Then you use your right triangle trig to find I hat and j hat, which are the legs of the right triangle. And you figure out what's positive and what's negative. You do have to remember that I hat is always the x part, and j hat is the y part, or the horizontal and the vertical parts. And then you write your final answer where you put it all together so that you have the rectangular form. Is that making sense to everybody? Looks like a couple of you still have heads going up and down, so I'll wait a moment before we move on. I'm going to have you guys do one whiteboard one on your own for some practice. Anybody need me to wait? Unmute or type a W real fast. And did I still need to go back to this example 3? Okay, so I got a no on that. All right, so now just one for you guys to do on your own. Following these steps, let's see what you can do for 42 at 340 degrees. The first thing I want you to do is to figure out what quadrant that's in and draw an arrow at about the right spot for 340 degrees and label that that arrow is 42 units long. Okay, type in chat, which quadrant are you putting that in? 1, 2, 3, or 4? And hit enter. So great job. We're going to put it in the 4th quadrant. And it looks to me like it needs to be closer to the x-axis than the y-axis. So I'm going to draw it. Oops, we'll try that again. Get it to look like one solid line instead of 3 dotted ones there. So I'm going to attempt to draw, it's supposed to be one line, but it's just being weird for me. So now we're going to extend that out here, and we're going to make a triangle. We must go back to the x-axis so that one side of our triangle is part of the x-axis. Now, how big is that reference angle? So that needs to be this angle inside the triangle. Type in chat how big that angle is. Okay, so good job. It is 20 degrees. And in this 4th quadrant, Now type in chat, are we going to end up with plus plus, plus minus, minus minus, minus plus? What are we going to end up with for I hat and J hat? So just do a, so we know we're going to have to end up with plus and minus when we're all done. And we're going to label that that hypotenuse is 42 degrees. Okay, I hat needs to be your horizontal part and J hat your vertical part. So now I want you to set up just like we did on the two examples, I hat with the 42, J hat with the 42, and figure out how big I hat and J hat have to be. And you've said I hat needs to be positive and J hat negative, and see if you can write that in its rectangular form for me. And I'll let you guys do the rest of that on your own. And if you have it, type this in, and don't worry about the hats. Negative no 5, or plus or minus your number J. And then the I and J really have hats on them. What in the world did that do? Okay, and hit enter. Very good. Don't forget that you do need the I hats and J hats. I and J in there. That's what I'm talking about. You've got to have the I hat and J hat on your paper, even though the hats are hard to type. So 39.467 I hat, and that one was positive, and then the negative, so minus 14.365 J hat. Questions from anybody on what we've talked about today? Okay, then I want you to go ahead and start your homework. So let's see, what are we doing? No, because we're not doing that set today. Right now, you're going to be working on, what did I say was next? Set 53. So you're not going to have some of these to practice for a couple of days, but go ahead and work on 53. And see, what would be good off of 53 to do? Why don't you do 28 and 2? since those are a couple of even ones that I know have tripped you guys up some. Let's work on 2, 16, and 28. So let me write that down for you guys, maybe. Everybody have those three done. I don't know, do you want to go ahead and go to 52? I hope you, I'm seeing some heads not, shake no, so we'll wait and we'll grade 52 on Monday. It'll be a busy week, but that's okay. Don't forget you have a video lesson 55 that you're also responsible for. I taught 54, but I'm not teaching you 55 live and in person. So you must watch that video lesson this week. Also, I did put a note with my 7th hour. I had an appointment that was supposed to be at 4 something, and they called me last night and had to change it to early afternoon. So I will not be available for 7th hour today if you have questions. But if you have questions, either use the chat room so other people can see the same question, or email me, and I'll check those later on so that I can get back to you on whatever you wanted some help on. And I am going to then quit sharing, get back where I can see you guys better.